Experimental investigation of concrete partial replacement of fine aggregate with red soil and lime powder. Abstract: an experimental investigation is carried out to study the behavior of concrete by replacing the fine aggregate with locally available red soil. It involves a certain tests to find the quality improvement of concrete when red soil is added to it. The partial replacement of sand with red soil has been done according to the specific mix proportion to gain good strength in concrete. In past studies of the journal, main problem arising that increase of red soil is to reduce the strength of concrete and it absorb more amount of water. So in our project, lime powder is also added in the concrete to avoid the water absorption and porosity. In this project, it is preferred to analysis the strength of M20 concrete and the amount of red soil is to be added in following percentage such as 15%, 30% and 45%. Mechanical properties such as compressive strength, split tensile strength, flexural strength tests has been carried out for red soil mixed concrete and plain concrete to differentiate the strength and imperviousness in it. The tests are done during 7th, 14th and 28th days after curing. Keywords: red soil, lime powder, porosity, water absorption, imperviousness. Introduction. Nowadays there is a scarcity of sand and it has become very difficult to get sand easily in economical way. Overcoming of this problem is very essential to research the alternative materials. In order to fulfill the requirement of the fine aggregates, some alternative material must be found. Hence, in this project it is planned to carry an experimental work by preparing concrete blocks with partial replacement of fine aggregate by available natural red soil. Sand is a major material used for preparation of mortar and concrete and plays a most important role in mix design. In general, consumption of natural sand is high, due to the large use of concrete and mortar. Hence the demand of natural sand is very high in developing countries to satisfy the rapid infrastructure growth. So we used red soil in these project. Red soil availability is in all kind of areas and it has unlimited resources in all areas which can be effectively used for admixture of concrete in constructing buildings. Red soil is formed due to weathering of igneous and metamorphic rocks. It is highly impervious after it is mixed with concrete because of its size, and its color is in red due to the presence of iron in it. In India regions, the availability of red soil is in Tamil Nadu, Karnataka, Andhra Pradesh, Orissa, Jharkhand, and it is also available throughout the world. In this study red soil is taken from Kolamavar Pudukottai, Tamil Nadu. Materials: cement. Ordinary Portland cement grade 43 has been used in these concrete. Fine aggregate. Locally available nature river sand to be used. Coarse aggregate. A well-graded nature aggregate to be used in the concrete. Red soil. A normal local available red soil is to be taken in these project. Lime powder. A fine lime powder is to used in concrete, even it will give good result. Thus, hydraulic lime is best one suitable for concrete. Objectives: to increase the strength of the red soil mixed concrete compared to conventional concrete. To reduce the usage of fine aggregate in concrete. To reduce the porosity and water absorption of red soil mixed concrete. To achieve high strength with more economical properties of materials. Cement. The cement is a binding material. It conforming to IS 456-2000-53 grade. It consists of grinding the raw materials, mixing them intimately in certain proportion depending upon their purity and composition, and burning them in a kiln at a temperature of about 1300–1500 degrees centigrade, at which temperature, the material sinter and partially fuses to form modular chapped clinker. The clinker is cooled and ground to a fine powder with addition of 2 to 3% of gypsum. The product formed by using this procedure Portland cement. Of all the materials that influence the behavior of concrete, cement is the most important constituent, because it is 11 used to bind sand and aggregate and it resists atmospheric action. Fine aggregate. The materials smaller than 4.75 mm size is called fine aggregates. Natural sand is generally used as fine aggregate. In this experimental work, replacement of river sand, fineness modulus of crushed sand equal to 3.2, conforming to grading Zone 3 of IS 383/1970 was used as fine aggregates. Coarse aggregate. Locally available well-graded granite aggregates of normal size greater than 4.75 mm and less than 16 mm having fineness modulus of 2.72 was used as coarse aggregates. The size of aggregate should be 20 mm size. Red soil. Red soil is rich in iron oxide, but deficient in nitrogen and lime. Its color is mainly due to ferric oxides occurring as thin coatings on the soil particles, while the iron oxide occurs as hematite or as hydrous ferric oxide. The color is red, and when it occurs in the hydrate form as limonite, the soil gets a yellow color. Ordinarily the surface soils are red while the horizon below gets yellowish color. Testing of materials. Cement. Specific gravity. This test is done by Le Chartelier's apparatus. And the value of specific gravity of cement is 3.14. Fineness test. The fineness value of the cement is 3.63% from 1 kg of the cement sample. Initial and final setting time. The initial and final setting time of the cement is done in Vicat apparatus. The determined value of initial and final setting time of cement is 30 minutes and 600 minutes respectively. Fine aggregate. Specific gravity. This test is done by Le pycnometer apparatus. And the value of specific gravity of cement is 3.14. Void ratio and porosity. The void is also done in pycnometer. That value is and use the relation to determine the porosity value as 0.409 and 29.02%. Sieve analysis. The sieve analysis is used to determine the fineness modulus and zone grading of aggregate as 3.11 and zone 3 respectively. Coarse aggregate. Specific gravity. This test is done by Le pycnometer apparatus. And the value of specific gravity of cement is 3.54. Sieve analysis. The sieve analysis is used to determine the fineness modulus and zone grading of aggregate as 2.69 and zone 3 respectively. Water absorption test. Basically, the aggregate doesn't absorb more amount of water. It absorb only small amount, that's 0.96%. Impact test. The test can be done in toughness test machine to determine the impact strength. The value is 16.30%. Shape test. The shape test are two, such as flakiness and elongation test. It's mainly to determine the shape, thickness, and length of the aggregate. Red soil. Specific gravity. This test is done by Le pycnometer apparatus. And the value of specific gravity of cement is 2.71. Void ratio and porosity. The void is also done in pycnometer. That value is and use the relation to determine the porosity value as 1.34 and 63.45%. Miscellaneous test. The liquid limit and plastic limit of the red soil is 75% and 40% respectively. Then the plasticity index of the red soil is 31.43. Mix design. Mix design can be defined as the process of selecting suitable ingredient of concrete and determining their relative proportion with the object of producing concrete of certain maximum strength and durability as economically as possible. Manufacture of concrete. Production of quality concrete requires meticulous care exercised at every stage of manufacture of concrete. If meticulous care is not exercised, and good rules are not observed, the resultant concrete is going to be of bad concrete. Therefore, it is necessary for us to know what are the good rules to be followed in each stage of manufacture of concrete for producing good quality concrete. 1. Batching. 2. Mixing. 3. Placing. 4. Compacting. 5. Curing. Batching. Batching is the correct method of measuring the materials. For important concrete, invariably, weigh batching system should be adopted. Use of weight system in batching facilitates accuracy, flexibility, and simplicity. Different types of weigh batchers are available. The particular type to be used depends upon the nature of job. When weigh batching is adopted, the measurement of water must be done accurately using measuring jars. Mixing. Hand mixing is practiced for small-scale concrete works. Hand mixing should be done over an impervious concrete or brick floor of sufficiently large size to take 1 bag of cement. Spread out the measured quantity of coarse aggregate and fine aggregate in alternate layers. Pour the cement on the top of it, and mix them dry by shovel, turning the mixture over and over again until uniformity of color is achieved. This uniform mixture is spread out in a thickness of about 20 centimeters. This operation is continued till such a good uniform, homogeneous concrete is obtained. It is of particular importance to see that the water is not poured but it is only sprinkled. Water in a small quantity should be added towards the end of the mixing to get the just required consistency. At that stage, even a small quantity of water makes difference. After that the red soil is placed in concrete at the different percentage of concrete and lime powder is also added to concrete at half of the quantity of red soil. Placing. It is not enough that a concrete mix correctly designed, batched, mixed. It is of utmost importance that the concrete must be placed in systematic manner to yield optimum results. The precautions to be taken and methods adopted while placing concrete in the molds. Compaction. Hand compaction of concrete is adopted in case of small concrete works. Sometimes this method is also applied in such situation, where a large quantity of reinforcement is used, which cannot be normally compacted by mechanical means. Hand compaction consists of rodding, ramming or tamping. When hand compaction is adopted, the consistency of concrete is maintained at a high level. Tamping is one of the usual methods adopted in compacting roof or floor slab or road pavements where the thickness of concrete is comparatively less and the surface to be finished smooth and level. Curing. Concrete derives its strength by the hydration of cement particles. The hydration of cement is not a momentary action but a process continuing for long time. Curing can also be described as keeping the concrete moist and warm enough so that the hydration of cement can continue. More elaborately, it can be described as the process of maintaining a satisfactory moisture content and a favorable temperature in concrete during the period immediately following placement, so that the hydration of cement may continue until the desired properties are developed to a sufficient degree to meet the requirement of service. The casted cubes and cylinders are immersed in water tanks for 7 days, 14 days and 28 days. Testing of specimen. The cubes were tested for compressive strength in compression testing machine and the cylinders were tested for split tensile strength same as compression testing machine but the position of cylinder in horizontal position and take the accurate result and flexural test was tested in flexural testing machine then noted the result with respective ages of curing as 7, 14, and 28 days. Result and discussion. Results of the test on concrete samples are given below. For 15% red soil, both the compressive strength, split tensile strength and flexural strength were increased compared to plain concrete in all days. For 30% red soil, both the compressive strength and split tensile strength were increased in 7 days respectively, result in 14 and 28 days compared to plain concrete specimen. For 45% red soil, both the compressive strength and split tensile strength were decreased compared to plain concrete in all days. For both 15% and 30% replacement of sand by red soil, both the compressive, split tensile strength and flexural strength were increased from plain concrete specimen with 0% red soil while loading in all curing periods. Overall, the most improved compressive strength, split tensile strength and flexural strength were found for 45% replacement of sand by red soil as it showed almost similar compressive and split tensile strength in 28 days of curing period, but both the strength were decreased in 7 days of curing because concrete absorbed more water with increase of soil. Conclusion. The test results was that the red soil mixed concrete is comparatively higher than plain concrete in strength and imperviousness. In compressive strength for 28 days, for plain concrete the values is 19.6 N/mm2 and in red soil mixed concrete it has higher the values 22.3 N/mm2. Experimental observations also reveals that the strength of the concrete is also well improved when the red soil get mixed with lime powder. The red soil mixed concrete of compressive strength, split tensile strength and flexural test are more strength compared to the conventional concrete.